Hello folks, I'm AB's journeyman smith Shibainu. Today I'm going to use scrap metal from these plates. Specifically, they are MagnaCut and Nitro-V to make stainless Damascus steel. This is my first time using high carbon stainless to create Damascus steel. Will everything go smoothly? Let's find out.
I cut the scrap material from the steel plates. Next, I use a surface grinder to remove the oxide on the surface and grinding to 120 degrees. Since it's leftover material, there were many pieces, so I could only make an 11-layer Damascus. There are 6 layers of Nitro-V and 5 layers of MagnaCut. The billet dimensions are 1/4 by 1.5 by 2.1 inches. After starting them, I use a clamp to hold them in place for welding. I used 308 stainless welding rods, repeatedly stacking 3 layers on the outside as a protective shell, and then weld 2 pieces of mild steel on the top and the bottom as sacrificial layers. Now, it's time for heating. I place the thermometer against the billet to measure temperature. This is my first time forge welding high carbon stainless steel, so I had no idea what temperature to heat it to. I ended up heating it to 2230 Fahrenheit before starting the weld. I know that welding stainless is very challenging, so I proceeded down a little bit at a time, about 0.08 inch thick, repeating the process multiple times. After completing the forge welding, it's time to stretch it. This is a very challenging moment because if the welding fails, the layers will delaminate. We could see that the mild steel was beginning to delaminate during the stretching, but that's okay. It was originally intended to be an outer layers to retain heat. After completing the first forge welding, I reheat the billet to 2200 Fahrenheit and then press it in vermiculite to cool slowly. Letting it cool for 4 hours, the most exciting moment arrived. I used an angle grinder to remove the 308 shell, and it looks like the weld turned out pretty well. There are no noticeable black lines between the layers. After etching with ferric chloride, the layer pattern becomes visible. The silver layers are MagnaCut, and the black layers are Nitro-V. Next, I need to flatten and stretch it to a size suitable for making a knife. During the side forging, there was no delamination, which means the welding was very successful. After forging, I reheat it and press it in vermiculite to cool slowly. After the steel cooled, I used an angle grinder to remove the oxide layers from the edges. However, this time the oxide layer was very deep. The width of the steel after forging was 1.5 inches, but after grinding, it was reduced to just 1 inch. So, I decided to use edge forging to stretch out some additional width. Considering the characteristic of MagnaCut, I followed Larry Thomas's recommendation and used a forging temperature of 2100 degrees Fahrenheit. Everything went smoothly, and the steel didn't delaminate from the sides. The world's first MagnaCut Damascus knife is about to be completed. I feel like I'm about to achieve a big success, and then I'll become the god of a new world. Okay. After going through the 5 stages of grief, I decided to finish it anyway. The first step is to fully anneal it. I used 2 layers of stainless foil to warp it, preventing excessive oxidation during the prolonged annealing process. I placed it in an electric kiln, heat it to 1650 degrees Fahrenheit, and then allowed it to cool down to 1100 degrees Fahrenheit over 8 hours. After annealing, the steel becomes quite soft, making it easy to cut and drill. Next comes to the familiar knife making steps, which I will briefly cover. First ground the surface, then the profile, and finally the bevel. After that, I press the knife into stainless bags and put it in the electric kiln. I added charcoal inside the kiln to burn off the oxygen, then quenched it using aluminum plates. After quenching, the blade surface looked quite clean. The next step is to perform cold treatment using dry ice. I clamp the knife between two steel plates to prevent it warping during the cold treatment. After the cold treatment and 2 tempering cycles, I started grinding the bevel. I used ferric chloride to etch the blade, bring out the pattern. With that, the knife is complete. Finally, let's review this experiment. You can see that the silvery part, which is MagnaCut, shows signs of cracking along the edges. I speculate that there are 2 possible reasons for this. The first is that after forging, the steel was only slowly cooled and not annealed. As a result, microstress fractures may have formed inside the steel, which then expanded and worsened during subsequent forging. The second is that decarburization of MagnaCut. After the first forge weld, I ground off the protective 308 welding rod shell, which may have led to continuous cracking from the decarburization area during subsequent forging. This seems quite likely because after the first weld, I quickly reached the clean weld layer once I removed the 308 shell. However, after the second forging, I had to remove a considerable amount of material. So, if I'm going to conduct another experiment, I might proceed as follows. 1. Avoid grinding off the outer welding material. 2. After each forging, perform a stress relief annealing after slow cooling in vermiculite. 3. Once the seal is forged into a plate, use the stock remove method instead of forging the knife frame. That concludes my documentation and reflections on this MagnaCut and Nitro-V Damascus steel experiment. I hope you all enjoyed it. May the sharp edge be with you.